Hi everyone, my name is Pradyumn, and today we'll discuss the solution to the first five problems of today's CF round, which was Div 1 plus 2. But before we begin, I'll tell you about our courses at TLE Eliminators. So, if you are someone who is stuck at just solving one or two problems per contest, our self paced courses is exactly what you need. We have structured the program into four levels so that you can start from wherever you are: beginner, pre intermediate, intermediate, or advanced. You'll learn the most relevant CP concepts through recorded lectures by experienced educators, followed by practice problems combined with guided hints and detailed video solutions that help you understand the why and not just the how. We believe in helping you build real intuition. If you need more help, you will get doubt support, instant doubt support from our high rate mentors so that you are never left stuck. And beyond learning, you'll enjoy leaderboards, gamified progress tracking, internal contests, and PCDs to keep you consistent. Pick the level that fits your goals and start learning today. If you want to know more about specific course, like specific level, then you can watch the you can see the page. And if you want to know that how to choose a level, you can see this video in which we explain that how you can choose a level which is correct for you. And if you need even more information, you can watch the level specific video, which outlines all the necessary things, which are like prerequisites, outcome, difficulty, and topics. So, all right, let's begin with the PCD now. Okay, so this was the contest. The first problem was an array is called balanced if every integer x that occurs at least once occurs exactly x times in the array. For example, 1424442 is balanced, but 2 and 222 are not. Because 4 occurs 4 times, 2 occurs 2 times, 1 occurs 1 time. You are given an array A of n elements, A1 to An. The array the array may not be balanced currently, and you can delete some elements to make it balanced. What is the minimum number of elements that you need to delete to make the array balanced? Okay, so this is a problem which is like pretty easy. Like what they are saying is you have an array A1, A2, A3 to An, and it is called balanced. It is called balanced if um, any element x in the array appears x times. So x should appear x times for every x in the array. Then it is called balanced. Like then the entire array is called balanced. Okay. So we have what we can do is we can delete some elements and to make the array balanced, and we want to figure out that what is the minimum number of moves that we need to do, right? So let's look at some samples. Let's say we have this sample test case. Okay, 1 2 3 2 4 4 4 5 2. So so basically we have I'll sort this array. 1 2 2 2. We have three twos. 3 4 4 4 and 4 4 4 4 and 5. Right. So 1 we have in the array, and we need to ensure that it is only once. So okay, it is only once, right? So we don't need to do anything. Then there is 2 in the array, and we need to ensure that it appears only once. I mean, sorry, only twice. Okay. So what we can do is we can delete this 1 2. So now there are only two twos. Then we have a 3 in the array, and we need to ensure that it appears 3 times. But we have only one instance of it. So how can we make it 3? We can't make it 3, right? So we have to make it 0. Like we have to delete all instances of 3 because we can't really make it 3 times. Either we want to ensure that it is 3 times or it is 0 times. So we can only make it 0 times, so we'll do that. Also note that in this 222 also, we could have chosen to delete all of these three twos, right? But that is worse. Like of course, if we have option to delete either only one element or to delete three elements, then we'll delete only one element, right? Because we want the minimum number of moves, right? So we delete this one too. Then for 3 we have only one. So we'll delete that. Okay. Then for 4 we have four fours. So we will keep them as it is. And this 5 is also single. So like either we need five fives or we need no fives. So we will delete all the appearances of 5. That is only one. So we deleted 3 elements, and that is the minimum. So it's pretty simple that basically for each element x should either occur x times in the final array, or it should occur or 0 times, right? So if any element is there in the array originally and its frequency is y, then if y is greater than x or greater than equal to x, then you will make it x, like by deleting the other elements. So you can delete y minus x elements and make it x, right? And if y is less than x, if y is less than x, then of course you cannot make it x, right? So you will make it 0 by deleting all the y elements, right? So for every element, you will just calculate this frequency of it, and if that frequency is greater than equal to x, then you will add y minus x to the answer. Like you will do this many deletions for that element, and if y is less than x, then you will do y deletions for that element, right? So this is what you need to do. Like you can simply make a frequency array and then just iterate over all the elements, right? Yes. So I'll just show the code now. The logic should be pretty clear. So we have int n cnn, take the input of the array and make the frequency map. Frequency map, I'm using std map. You can use array as well because the numbers are bounded till n. So you can make a frequency map of size n plus 1. Frequency array of size n plus 1. So I just increment the frequency. And for every element in the frequency array, if y is greater than equal to x, then answer plus equals to y minus x. Otherwise, the answer plus equals to y. And finally, I say out the answer. This mi variable I have made, but it is not used. Like I made it by mistake. So just ignore that. Finally, we print the answer. Yes. So that's the code. So is there any doubts, anyone? Is anyone there? Like this PCD was scheduled very late, so you might have you might get the notification late. So how many of you are there? No doubt. Okay, Ishan, Gaurav, thank you. And Frank, like I don't know what's your name. Anyways, so let's move on to problem number B now. B is called expansion plan 2. You are analyzing an infinite grid with coordinates x, y. Specifically, the cell immediately above 00 is 01 and cell immediately on the right of 00 is 10. Initially, only the cell at 00 is black. You are given a string A1, A2 up to AN of length n, consisting of characters 4 and 8, which describes n expansion operations. For each I from 1 to n, the following happens for all cells simultaneously. If Si equals to 4 for each cell, if it is orthogonal adjacent to a black cell, that is, it shares a side, it becomes black. Otherwise, its state remains the same. And if Si equals to 8, then for each cell, if it is orthogonally or diagonally adjacent to a black cell, that is, it shares a side or a corner, it becomes black. Otherwise, its state remains the same. Okay. Is the cell XY black at the end of the process? So we have to um, check if the cell XY is black at the end of this process. So basically, what they're saying is what we have is an infinite grid, right? We have an infinite grid, and initially only the cell 00 is black. Okay. And adding operation, like either we perform a 4 or we perform an 8, right? So if we do a 4, then what happens is all the cells adjacent to a black cell will get black. So like, okay, yeah, so this is cell black, this cell is black. So if we perform a 4 operation, then all the cells adjacent to a black cell will color black. So like in this case, all of these 4 cells, they will be colored black, right? And if we do an operation 8, like let's say in the starting position, we do an 8 operation. So in 8 operation, all the cells which share a corner or a side with this black cell will color black. So will get colored black. So we'll color all of these cells as black, right? So let's say we perform an 8 operation like this, and then we perform a 4. Okay, so we performed 8, then we perform a 4. Okay, so 4 means like you will simply color all of these cells. This one, right? So actually, this diagram is not very helpful. Like it is not very neat. So I will explain using the CF diagram. Like on the code forces, they have given very nice diagrams. So I will explain using that. Right. So as you can see here, we have the starting square, right? And if we do an 8, we will get like this, all the adjacent squares. And if we perform one more 8, we will do like this. And if you perform one more 8, then it will become like this, right? So that's one pattern. Then let's say we have 4884. So after a 4, it will be like this. Then you can see after an 8, it will become like this. Then after one more 8, it would become like this. And finally, it would become like this, like after you perform a 4. Okay. And similarly, you can look at these ones also. This is 4884. Like they are same. Okay. So, anyways, yeah. So what we have is like what you can observe here is a pattern. Okay. Like just see the 4884 case. Okay. So how does the black region look like? Like if you observe carefully, what does the black region look like? Like initially it is a square, right? Then it becomes like this. Like if you carefully look at this diagram, the final diagram, it looks like somewhat like you have these diagonal edges right here, right? Let me try to paste this. Yeah. So if you see, um, yeah. So here you can see that what you have is some diagonal type of thing, right? That is forming. And like first of all, this figure is symmetric from the y-axis and from the x-axis as well, right? And here, like this is a diagonal which is forming, correct? And also we have some bounds on here and here as well, like from on the left and right, and top and bottom. So basically, we have some bounds on this, like this, and also we have some bounds like this. And these are the only two type of bounds that we have to see. Okay. Like what I'm saying is, you can actually define this figure just by two lines. One is, I mean, sorry, like three lines, let's say. One is this line, the diagonal line, that is till what diagonal are the black cells there, and the horizontal line like this, and the vertical line. So if you know these three lines, then all the cells in this region, they will be black. Okay. So you can define the figure like this, and then you can check that for each operation, how do these change? Okay, I'll try to explain more intuitively. Like let's say in this figure only, if we do one more for operation, okay, I'll decrease my pen size. Yeah, so let's say in this figure, we do one more for operation. Okay, so 4 means, okay, initially let's draw the initial lines. Like diagonal line is this one. I'm drawing the initial one in greens. I'm drawing the initial lines in green color. Okay, so uh, yeah, so the diagonal line is this one. Vertical line is this one, and horizontal one is this. Right. Now let's say you do a for operation. Okay. So when you do a for operation, what cells will get colored? Let's see. So this one will get colored. This one, these ones, right? Okay, and also these ones. So finally, what happened? Like I'll draw the final lines also. So initially, these were the green, these green ones were the lines, and finally, the diagonal line is like this now. It has shifted one place. Then the horizontal line is like this, and the vertical line is like this. And as you can see, if you just um, look at the intersection of all these three areas bounded by these lines, then you will see that it forms a square exactly. Like this figure is formed by these three lines. So as you can see, the horizontal and like all three lines moved by ones. Like initially, this green line was here, right? And now it moved one place. And same for the horizontal and vertical lines. So they both move one place when we did a operation of 4. So when we do 4, all lines move by 1. Move by 1. And what if we do an 8? Let's try to do an 8 also. So I will erase the erase my changes. Okay. So now if I do an 8, let's see what happens. So initially these are the green lines, and now I'll do an 8. So 8 में क्या होगा? Like all of these cells would get colored. So this would get colored. This also would get colored like this. Okay. So I'll only do the top left part of it, top right part of it, I mean, because it is symmetric, right? So yeah, this is what will happen when we perform the 8 operation. I did the 8 operation now. So as you can see, the green one is now here, like the diagonal one is now here, I mean. Okay. And the horizontal one is here, horizontal one, and the vertical one is here. So you can see the diagonal one actually shifted two places. Like if you see carefully, um, this green line, if you can see, it shifted once. It would become like if it shifted once, then it would come here, and it shifted twice, so it came here, right? So basically, the diagonal one shifted twice. Uh, where did the figure go? I think it is lost. Well, this is annoying. Okay, let's try to draw it. Okay, let's try to just open a new OneNote. R note, I mean, sorry. Yeah, so what I was saying, we have this thing right here. And initially, the green lines were like this. Like initially, the diagonal line was here, and the vertical line was here, and this one was here, right? And when I did the 8 operation, then the diagonal one moved twice, right? And the horizontal one moved once, and the vertical one also moved once. So that's what happens when you do the 8 operation. Diagonal ones move twice, and the vertical and horizontal ones they move once. And when you do 4 operation, all of them move once, right? So you can simply keep track of all the 3 lines and finally just check that is your final point in that region or not. Like that's the problem, right? You have to check if your final point lies in this region. So what you can simply do is keep track of these 3 lines. And actually, what are these 3 lines? Like you can actually write the equation of these lines using coordinate geometry, right? So like this is zero. Okay, this is zero. This is one. This is two. This is zero in y direction. Zero, one, two, three. Right. So the equation of this line is what? Let's say 4. So equation of this line is x plus y equals to 6. X plus y equal to 6. And equation of this line would be what? X plus y equal to 8. That is when we do a 8 move, this 6 increments by 2. Right. And what is the equation of this line? The equation of this line is y equals to 4. Right. And when we do the 8 operation, this line becomes this line, which is y equals to 5. So it increments by 1. Right. And similarly, this is like this was x equals to 4 and it became x equals to 5. So finally just check that what is the equation of these lines and whether or not your point belongs to the region just by checking it with the line equation. Like if you want to check that does your point lie in this region, then you just have to check that let's say the point is a comma b, then you just have to check that is a plus b less than equal to k or not. Like if your line equation is x plus y equals to k, then you can check if a plus b is less than equal to k or not. Okay. So this explanation was quite rugged actually. Like it hit me, so it hit me. Like I don't know if I gave the intuition correctly or not. Like I tried to explain my best, but if someone still has a doubt, then I'll try to explain it one more time. BFS TLE. Um, because like it is O of n square, right? In fact, O of um, yeah, like even if you do BFS after like only the borders, then also it will give TLE. I mean, see, the size of the figure is increasing, right? Like initially it is 1, then it is approximately 2, then it is 3, then it is 4. Like if you just count the number of nodes on the edge, like here 1, 2, 3, 4, 5, 6, 7, 9, 10, and maybe this one also will count. So 11, 12, 13, 14, and 10. So 24 squares. So like if you just count the number of squares on the border, it is increasing linearly, right? As the figure grows, it will be approximately 4 into n, right? And For all of them, you are doing n operations. Like at each step, you are simulating, right? So at each step, you are performing n operations. So it is O of n square. Like at the step I mean, you are doing I operations or 4 into I operations. So if you take the sum of it, then it is O of n square. Yeah, I have a pen tab. Um, so I think you all might have some doubt. No doubts? I will just explain once more that what I am doing exactly. So what I am doing is I just observed that whatever the figure is made, like using the operation that we described, we the figure that is made, like this figure here, that is made, is actually always described by just three lines. Like you can just draw a diagonal line like this, a vertical line like this, and a line like this. And you can see that these three lines describe the entire figure. Like any points in this region lie on the figure, right? So what you can do is just keep track of these three lines. Like when you perform an operation number 4, then this diagonal one shifts by 1. Like it shifts to this, and vertical one also shifts like this, and this one also shifts like this. So you can just keep track of the equation of these lines. And finally, whatever the point they have asked, you can just check that is it in the bounds or not. Okay. Like here, for example, I'll show you how it changes. Okay, so initially, the lines look like this. The diagonal one is at 0. This is at 0 0. This one is also at 0 0, and the vertical also is at 0 0. Okay. Then if you do the operation 4, then the diagonal one moves by one step, right? The vertical one moves by one step, and the horizontal one also moves by one step. So now these are the lines. So like x plus y equals to 1, and also x equals to 1, and y equals to 1. Then when you do 8, the diagonal one shifts by 2. So this diagonal line ki equation is now x plus y equals to 3, and the vertical one shifts by 1. So y x equals to 2, and this one is y equals to 2. Then similarly again, for this thing, you can see that this line equation is x plus y equals to 5, and x equals to 3, y equals to 3. And finally, if you do 4, then this diagonal will move by one place. So x plus y equal to 6, and x equals to 4, y equals to 4. Right? And what your point is given what? 5 comma 1, right? Your point is 5 comma 1. So you have to check with the equations. Like this 5 comma 1, so 5 plus 1 less than equal to 6 is satisfied. So this point is definitely towards this, right? But what about the other two conditions? The vertical and horizontal one. So since this 5 is not less than equal to 4, 5 less than equal to 4 is not satisfied. So in the vertical direction, it is not in that range. So therefore, we will see that the answer is no. Okay. So this question actually like required a bit of coordinate geometry knowledge, but not very much. If you are studied in 10th class also, then you would know this. Okay. So I'll show the code now. The code is very simple. So I took the input nxy, and a is equal to 0, b equal to 0. So the a is basically like the line of, like I'm assuming that the lines are x equals to a and y equals to a, y equals to a, x equals to a, and x plus y equals to b. These three lines I'm assuming. So initially they are all 0, right? And if 4 occurs, then both a and b increase by 1. And if 2 8 occurs, then b increases by 2 and a increases by 1. And also I just take the absolute value, like because the figure is symmetric in all four directions, so I can just assume that, like, I can just take the mirror image of the point and make it in the first quadrant, right? So if it satisfies the conditions, that is x plus y is less than equal to b, and x is less than equal to a, and y is less than equal to a, then I'll see out yes, else I'll see out no. Okay, so that's how the problem is solved. Okay, understand, like the pattern, you saw the pattern. That's also fine. I read somewhat mathematically. Maybe in editorial they have some other approach. Let's see. Okay. So they have this approach. This is also pretty nice. Like it is similar only, but it gives something else. Like the logic is a bit different. Anyways, let's move on to the problem of C. It is not okay. Maximum array 2. Um, you are given you are given three positive integers n, k, and q. You are also given q tuples C L R with C between 1 and 2 and L R between 1 to n. An array A1, A2 up to An is maximum if AIs are between 0 to 9 for each I, and for each given tuple CLR. If C is 1, then min of AL to AR should be equal to K, and if C is 2, then max of AL to AR should be equal to K. Okay. Note that the parameter K is the same for all the conditions. Find a maximum array A1 to AN of length n. Okay. And it is given that it is always exist. Like the input is generated in such a way that a valid array always exists. If there are multiple, then you can print any of them. Okay. So yeah, what they are saying is we have um, an array. Okay. They have given us an array and a value k and some ranges, right? So we have an array a1, uh, a1, a2, a3 up to an, right? And what we also have is a value k. Okay. And what we need to do is, like, we have some ranges, like we have two types of ranges. We have two types of ranges, like type 1 and type 2. Let's say type 1 ranges and type 2 ranges. Okay, so in type 1 range we need that the minimum of al plus 1 up to ar is equal to k. Okay, and in type 2 range we need that the max of al plus 1 up to ar is equal to k, right? So we need this condition, like for all the ranges of type 1 and type 2 we need these two conditions respectively, and if the array satisfies these two conditions for all the ranges, then it is called maximum array. Okay, so we have been given these ranges and also the integer k, and we have to, like, print a maximum array, like we have to print an array which satisfies these conditions. Okay, so let us try to figure out using a sample test case. So here we have a sample which is 622.113.226. So basically n is 6, that is we have 6 elements, 1, 2, 3, 4, 5 and 6. Okay. Then we have 113, that is this is a range of type 1. Okay. And then we have 226. So 226 means that this is a range of type 2. Okay. 2 comma 6. And so, okay, what does this mean? So type 1 range means the minimum is should be k. And what is k here? K is equal to 2. So we need that in these three elements, the minimum should be equal to k, right? And in these five elements, their max should be equal to k, that is 2. Okay. So basically, we need that this element should be greater than equal to k, this should be greater than equal to k, and this should be greater than equal to k, right? Okay. So now what we have is, um, like because we want the minimum of these three to be k, that means all of them have to be greater than equal to k, and also at least one of them has to be k, right? Otherwise, the minimum would be greater than k, right? So that's one thing. Now k equals to 2. Like, what about this type 2 range? Type 2 range means that we want the max of these five quantities to be equal to k, right? So what does max mean? Max means that all the elements from 0, 1 up to k minus 1, they should be there in these five elements, and also k should not be there, right? So that means that these two elements cannot be equal to k, right? Because k cannot be there, right? So these two elements cannot be equal to k, and also they have to be greater than k, right? So these two elements basically have to be greater than k, greater than k, greater than k. All right. And then the other three elements, they don't have any restriction. All right. But we just need to ensure that the max of these five elements should be equal to k. That means we should have 0 and 1 in these elements, right? All right. So let's just put a 0 here, let's say a 1 here, and let's say a 1 here, okay, or a 0 here, whatever. And here we need some elements that are greater than k, that is, let's say 3 and 3. Okay. And also we need that the minimum of these three elements should be equal to k. So we have to put 2 here, so that the minimum becomes 2. So this is one array which satisfies the conditions. Like this 2, 3, 3, the minimum is 2. And for this array 33010, the max is also 2. So this array is satisfied. Like this is a valid answer, right? So using these things, like using this like procedure, you can actually build an intuition about what we can do. Okay. So first thing that we observe from this sample test case dry run is that when we have a type 1 range, all of the elements of that range have to be greater than equal to k. That is one constraint that we always have to follow, right? And also, when we have a type 2 range, when we have a type 2 range, then all the elements which are less than k, that is 0, 1, 2, 3, up to k minus 1, all of these elements have to appear in this subarray. And in fact, they cannot even appear where there's a type 1 range. Like if there's a type 1 range right here, like see, this element is there in this type 2 range also and in type 1 range also. So definitely it has to be greater than or equal to k because of type 1 range. So it cannot be less than k. So like these elements 0 to k minus 1, they will always be somewhere where there is no type 1 range, right? So like only these three elements can have these elements 0 to k minus 1. And we want that all of these numbers should appear at least once in the entire subarray, right? And also we have to ensure that here k does not appear, right? We have to ensure that k does not appear at this position. Okay. But we also have to ensure that the minimum is k. That is, k should appear at least once in this entire array, right? So greedily, what I can do is first I can try to make all of them k. All right. Like whenever there is a type 1 range there, wherever there's a type 1 range, I can just try to make all of these elements k. Okay. Let's try to do that. Like let's just put all the elements as k because I want the minimum of that to be k, right? The minimum of the subarray 1 should be equal to k. So every element should be greater than or equal to k. So let us try to put them as k. This is satisfied. Like this is well defined. Like if we have finally these three elements in our array, then the condition for the type 1 is satisfied. That the minimum is k. Alright. But here k cannot be there. Like because this element is in a type 2 range. This element is in a type 2 range. So this cannot be equal to k. So we have to make it something greater than k. Let's say we make it k plus 1. Right. And actually, whatever we make it like k plus 1 or k plus 2 or k plus 3, it doesn't matter because it will not be the minimum. K will be the minimum. So whatever we put, it doesn't matter. And also, when we take the max of these elements, all we want is that we should have 0, 1, 2, 3 up to k minus 1. And we should not have k. But what we have after k, it doesn't matter. Like whatever I have k plus 1 or k plus 2, it will not affect the max if I don't have k in the subarray, right? That's the thing. So I can actually put anything right here. So let's say k plus 1. Or we can even put 1e9, 1e7, whatever we want. Like I just put k plus 1 here. So basically my algorithm is that I am putting the value k in all type 1 ranges except for the places where it can't be k. That is in those cells which appear at type 2 range as well. So any cell which appears in both type 1 and type 2 range, I will put as k plus 1. And all those cells um, which have only type 1 range, I'll put k. Alright. And whatever cells which have type 2 range only, like see, in each type 2 range, let's say I have multiple type 2 ranges. Let's say this one, and this one. Okay. So I need to ensure that every type 2 range has all the elements from 0 to k minus 1. Right. And for now, just assume that there are no type 1 ranges. Like these are all type 2 ranges. This is type 2, this is type 2, type 2, type 2. Okay. And here, let's say k is equal to 3. Then what can be a possible assignment that you can give? Like if I have these four ranges and like n equal to 7 right here. We want to place 7 elements and k is 3 and these 4 ranges are there of type 2. Then what is the one possible configuration that you can do? Like can you give me an array? Like if I have this input that I have this range of type 2, this range of type 2, this range of type 2 and this range of type 2, then can you give me an array which satisfies the conditions where k is equal to 3? Mod k. Yeah, basically the index mod k. Like if I basically 0, 1, 2, 0, 1, 2, 0. Like if you just do like this, then you can see that every contiguous array of size 3 will have all three numbers, right? So anything bigger than that will also have all three numbers, and that's why we can always do this, right? Okay. So basically, in all those elements which don't have a type 1 element in them, we can just put like this, like I mod k. Like basically, let's take a test case. Let's say my k is equal to 3, and this is a type 1 range, this is a type 2 range, okay, and this is a type 1 range, okay. So here, all the type 1 ranges I'll fill with k first, okay, right. But now this element is in type 2 range also, so I'll make it k plus 1, okay. And then for the rest of the elements, I can just fill them cyclically. Like here, I'll just mark the indexes 0, 1, 2, 3, 4, 5, 6, 7. So I can just fill 4 mod 3, which is 1, 5 mod 3, which is 2, and 6 mod 3, which is 0, and 7 mod 3, which is 1. So here you can see that this two length array is filled with all the numbers from 0 to 2, 0, 1, and 2, right? And this k plus 1 is like 4, right? So the max of this subarray becomes 3. So here's the algorithm. Like the algorithm is basically fill all type 1 cells with um, with k, right? Fill all type 1 2 cells with k plus 1 or any value greater than k, right? Any value greater than k. And third, fill all type 2 cells with I mod k, right? And this will ensure that every k length contiguous subarray will contain all the numbers from 0 to k minus 1, right? And so this is how our solution will work. Yeah, like if the answer exists, then our algorithm will be able to find it. Like intuitively, it makes sense. I guess someone might ask that what if we have a type 2 range? Like let's say k is equal to 3, 0, 1, 2, 0, 1, yeah, 0, 1, 2, 0, 1. And let's say this is type 1 range. Okay, so let's say we have this is type 1 range and this is a type 2 range. Okay, so what about this case? So in this case, actually, the answer cannot exist. Like, okay, in my algorithm also, um, what I'm doing is 0, 1 and 0, 1, and here k will be there, which is 3. And these cells are not part of anything, so we can just fill them with any number that we want. Let's say k, 3, 3, 3. Or let's say 0 only. Let's say we fill it with 0. So in this case, my algo doesn't work because this type 2 subarray doesn't contain um, all those values from 0 to 2. Like 0, 1, and 2 is not contained there. But the thing is that it is not possible to satisfy this condition. Like if this is the input, then the answer is not possible. And why is that? because this type 1 range is fully enclosed in this type 2 range, right? And since this type 1 range is minimum, like since iska minimum has to be equal to k, that means that this type 2 range will have a k somewhere in it. Like this type 2 range will have a k somewhere inside of it, and that is not allowed because our max is equal to k. So basically, if a type 2 range encloses a type 1 range completely, like if this is type 2 range and this is type 1 range, this is type 1 range, then it is not possible. Okay. So in a valid input, anytime only type 2 range can overlap partially with a type 1 range. So this is a type 2 range and this is a type 1 range. So definitely if it is like this, then we will always have some contiguous portion that we can use. Like if you determine that, let's say the places where type 2 intersect with type 1, like in this cell, so this cell is not usable. Like basically you cannot insert a number which is less than k into this cell, right? So this is unusable and this is also unusable. But the usable cells that you have, they will all be in a contiguous form. So if you just fill I mod k, then you are guaranteed to have all the values from 0 to k minus 1 at least once, assuming that you have enough number of cells. And like if you don't have enough number of cells, then of course you cannot, it is not possible to fill all of them, right? So this is why um, our algorithm works. Type 2 range should be of size containing all values less than k. Yeah, like in fact, the usable values of type 2 range should be at least k, greater than or equal to k. Like you cannot have something like this. Let's say type 2 range, this is type 2 range, this is a type 1 range, and this is a type 1 range, and k is equal to 3. So you want that in this type 2 range, you should have 0, 1, and 2, right? But you cannot have 0 and 1 in these two positions because they are intersecting with type 1 range. So you have only two positions, but you have three numbers to fill. So it doesn't work. So basically, the prerequisite of a valid input is that all the type 2 ranges should not contain any type 1 range completely. Okay, so like, yeah, that's why this is not possible because this type 1 range is completely contained in this type 2 range also. That's also one thing. And another thing is that the number of usable elements in every type 2 range should be greater than or equal to k, so that you can fill all the numbers from 0, 1, 2 up to k minus 1 inside that type 2 range, right? So actually, I did not think of this proof while solving the problem. I just did it intuitively. Like I just did I mod k and it worked. So yeah. So any other doubt? No? Okay. Alright, so let's see the code now. I have nkq, seen nkq. Vector of pair, like I am just storing the queries. Like type 1 ranges I am storing in vector of pair A, and type 2 I am storing in B. So if C is equal to 1, then A dot push back L minus 1 R minus 1. Otherwise, B dot push back L minus 1 R minus 1. Minus 1 because 0 indexing, right? Then I have the ans vector initialized to all zeros. Okay. Then for all the type 1 ranges, I will fill them with K. And I am doing it in O of n into Q. So it is allowed, right? O of n into Q is allowed in the constraints. N is up to 100 and K is up to 100 and T is up to 500. So T into n into K is allowed. I mean T into n into Q. Q is still 100. So T into n into Q is also allowed. So I am doing it in that complexity. So yeah, for all the elements in a type 1 range, I am making their answer equal to k. Like I'm just filling k in there, and then um, I'm just storing a copy of this ans vector. Like basically now what I need to do is wherever I have a type 1 element, like wherever I have filled a k, if I have a type 2 also there, I will replace it with k plus 1, right? So for that, I'm just storing the temporary variable. Like I'll just modify this ans, but I'll check if the temp had a value of k to know if I have a type 1 range there or not. Okay, so for all the type 2 ranges, I'm iterating over that range, and if that temp contained k, that means I had a type 1 range. Like, right? The position I had a type 1 range, so I'll make it k plus 1. Like basically this position I has both type 1 and type 2 range at this point. So it will be k plus 1. Otherwise, it has only type 2 range, so it would be I mod k, right? So and I'll print the answer. Okay. Estimate difficulty, we can use C list. Okay, actually C list पे दिखा नहीं रहा है आज का शायद. Like yeah, C was around 1400, I guess. Like it is a greedy approach, uh, or we can say 1500 as well. I mean, I guess. Anyways, like C was a pretty nice problem actually. It is pretty elegant, to be honest. But yeah, let's move ahead with the problem number D. You are following the World Championship of the billion players game. There are 10 to the power 9 players competing, and you want to predict the final ranking P of Godflex, your favorite streamer. After analyzing the recent matches, you are sure that P is between L and R, but you don't know anything else. There are n offers made by the in-game bookmaker. In the ith offer, the bookmaker suggests an estimation AI for Godflex's final ranking. For each offer, you must choose exactly one of the following actions: ignore the offer, accept the offer by claiming that P is less than equal to AI. If you are right, then you will earn P minus AI modulus RoboCoins. Otherwise, you will lose modulus of P minus AI RoboCoins. Or you can accept the offer by claiming that P is greater than equal to A of I. If you are right, then you will earn mod of P minus AI RoboCoins. Otherwise, you will lose mod of P minus AI RoboCoins. After you decide how to deal with all the offers, the actual billion players game is played. Godflex gets a position P in L, R, and then all the offers are settled up. Your total score is the number of RoboCoins that you are guaranteed to earn. That is the minimum number of RoboCoins you earn over all the values of P in L, R. Find the maximum possible score you can guarantee. Okay, so what is happening here is that we have some tournament, okay, in which some player is playing. A player P is there who is playing in some tournament, right? And he will get a final rank of P. And we know that P will be between L to R. Like we know the skill of this player, so we know that this ranking will definitely be in this range L, R. Okay. Then what we know is there is a betting competition, right? And we can bet n types of bets. Okay. Like there's an array which is given A1, A2 up to AN, and we can bet n types of bets. That is basically, um, let's say we take this A3. Okay. So what we can do is either we can bet that the final score, the final ranking of P will be greater than or equal to A3. Okay. So if we bet this and we win, then we will get mod of P minus A3 coins. Otherwise, we'll lose mod of P minus A3 coins. Like if we win, then we'll gain this much, and if we lose, then we'll lose this much. Right? Or we can bet that P is less than or equal to A3. That is, if this p is less than equal to a3, then we will win this amount, mod of p minus a3. Otherwise, we will lose this amount, mod of p minus a3. Okay. Or we can just choose to not do anything about this. So in that case, it is 0. Okay. So for each type of bet, like from A1 to AN, we have to choose that do we want to bet it higher or lower, right? Okay. And finally, like whatever is the worst case scenario, like whatever the value of P is, through which we are getting the worst possible outcome, we have to maximize that. Okay. We have to place our bets in order to maximize the worst case outcome. Like for example, we have this sample right here. Let's say our sample contains only two numbers, 50 and 200. Okay. So there is one bet of 50 and there is one bet of 200, and L equals to 100 and R equals to 100. So basically we know that the value of P will definitely be equal to 100. Okay. So if we know that the value of what is the final value of P, then what will you bet? Like for the first thing, we will bet that P will be greater than equal to 50. We'll bet this. Okay. And since we are right, we will gain the mod of P minus AI, that is 50 minus 100, which is equal to 50. So we gain 50 from this bet, right? And here the bet is 200. So we will bet that P will be less than equal to 200, right? And so our outcome would be mod of 200 minus 50, or 50 minus 200, right? 50 minus 200, which is equal to, sorry, P was 100, I mean. So it would be 200 minus 100. So we would have 100 gain from this bet. So 50 gain from this bet, 100 gain from this bet. So we'll get 150 gain, right? But let's say if we had bet that P would be less than equal to 50, then we would lose 50 points. So minus 50 would happen, right? And our net income would be 100 minus 50, which is 50. So of course, this strategy is better. Like we will bet that P is greater than equal to 50, and we'll also bet that P is less than equal to 200. So in both the cases, we will win, right? So this was a pretty simple case because we knew that what is the final value of P. But what if we don't know? Okay, then we'll have to analyze some different things. Okay, so here, let's say in the test case number 3, there are 5 possible values. Like the value of P can be either 6, 7, 8, 9, or 10, right? And depending on that, our bets will be evaluated. And whatever is the worst case, like out of these 5 values, whatever is the worst case, we would win that much. And we have to maximize what we are winning, right? Like, I think the question is pretty clear. Like, let's say my strategy is in this case, let's say I bet that P is less than equal to 9. Or, okay, I think the question is pretty clear. Like, I don't need to explain the problem more. So I'll move on to the solution now. Like, I'll give some intuition. Okay. So, first of all, this modulus of P minus AI, mod of P minus AI is actually, like, we can open this, right? Like, we can say that what is mod of X? Mod of X is basically X if X is greater than equal to 0. And mod of X is minus X if X is less than 0, right? So, what we can say is mod of P minus AI. Mod of P minus AI. So, this is equal to P minus AI if P is greater than equal to AI. And this is equal to AI minus P if it is Like if P is less than equal to AI. I mean less than AI, or doesn't matter really. Because in that case it is 0 only. So mod of P minus AI I can write like this. Okay. So now let's look at both the cases. Like let's say that I accept the offer and claim that P is less than equal to AI. Like let's say in the first case, I make a bet. I make a bet that P is less than equal to AI. Okay. Like final value of P, it comes out to be less than equal to AI. And let's say finally it came out to be X. Like the final value of P is some X. Okay. Then if X is less than equal to AI, then I win, right? So my gain is modulus of X minus AI, right? And if X is greater than AI, if X is greater than AI, that means my bet was wrong, right? I bet that P was less than equal to AI, but X turned out to be greater than AI. So actually, I lose this amount. That is, my gain would be minus of absolute of X minus AI, right? Now, if I try to open this, like let's say I try to open this X minus AI mod. Okay. So in this case, X is less than equal to AI. So mod of X minus AI is what? It is AI minus X, right? And in this case, X is greater than AI. So what is mod of X minus AI? It is just X minus AI, right? So this negative sign is there, and we have X minus AI. So this is basically AI minus X only. AI minus X. Like in both the cases, it turns out to be AI minus X. In both cases, our gain, that is how much we earned from this bet, turns out to be AI minus X. If we bet that P is less than equal to AI. Like basically, let's try to understand it more intuitively. Let's say AI is 5. Okay. If AI is 5, and let's say you bet that final value of X is greater than equal to 5. Okay. So AI is 5. Now let's say X turns out to be 8. Okay. X turns out to be 8. Then how much will you gain? See, you bet that X was greater than equal to 5. So you won, right? Because 8 is greater than equal to 5. So you win. And how much do you win? You win 3. Let's say X turned out to be 7. Okay. Then it is still winning. So you won 2 coins. Let's say X turned out to be 6. So you won 1 coin. Let's say X turned out to be 5. So you won 0 coins. But now let's say X turned out to be 4. Then you lost, right? You lost. And how much did you lose? 5 minus 4, which is 1. So you lost minus 1. Like what your gain is minus 1, right? So you can see if the x turns out to be 3, it is minus 2. So basically, if you bet that x is greater than equal to 5, then your gain would always be x minus 5. Like you can see, x minus 5 is coming out. Okay. Regardless of whether or not you lose, your gain would be x minus 5. You can say that. So if x is greater than equal to 5, then it is positive. And if x is less than 5, then it is negative. But in both the cases, your gain would be x minus 5 only. Okay. So until here, is it clear, guys? Like if you place a bet that P would be less than equal to AI, then if X turns out to be less than equal to AI, then your gain is AI minus X. And if X turns out to be greater than AI also, then also your gain is AI minus X. But in this case, it would be negative. Like this value is negative, the value of AI minus X. And this value would be positive. Okay. But in both the cases, A minus X is there. Right? And similarly, if you had bet, like if you had bet that your final value of x would turn out to be greater than p, I mean greater than ai. Like let's say your final value of x, you bet that it turns out to be greater than ai. In that case, let's say it turns out to be like, let's say if it is true, then your gain would be x minus ai. And if it turns out to be false, that is, if x turns out to be less than ai, then also your gain would be x minus ai, right? So basically, if you bet that p is less than equal to ai, then your gain is ai minus x, where x is the final value of it. And if you bet that p is greater than equal to ai, then your final value, like then your gain would be x minus ai. So you can see ai minus x and x minus ai. So basically, for all the bets, like for a1, a2, a3, up to an, okay, let's say that basically you have to choose, you have three options for every bet, right? Like for every value you have three options. Either you can choose the first option, that is a1 minus x, or you can choose second option, which is x minus ai, or you can choose third option, which is 0, right? If you don't bet anything, then you won't lose anything or gain anything, right? And if you bet that x is less than or equal to a1, then you will gain this much. And if you bet that x is greater than equal to a1, then you will gain this much, right? So for each of these numbers, you need to choose either ai minus x or x minus ai or 0, right? And finally, whatever your profit is, it is basically the sum of that. Like finally your profit is just like let's say you chose, like for some of these values you choose, some of these you chose blue, like blue means the first condition. So let's say for this one and this one, you chose the first bet, okay. And then for some red ones, let's say a2, a5, a6 and all, you chose the second one, okay. So let's call the blue ones bi, like let's say from b1 b2 up to bm, you chose the first option, okay. And let's say from c1 c2 up to cm, let's say ck or something, you chose the second option. Then finally your profit would be what? Your profit is just, see, from b1 what you will get, b1 minus x, because you chose the first option for b1. Then from b2 you will get b2 minus x, then you will get b3 minus x up to bm minus x, right? And also you place the other bets, you place the type 2 bets as well. So that would give you x minus c1 plus x minus c2 plus up to x minus ck, right? So this is your final profit basically, like depending upon the value of x, whatever is the final value of x, this is your profit. If you place your bets like this, like you had n options, right? And you can choose some of them as type 1 and some of them as type 2 and the rest of them as type 3, that is no bet, right? So let's say you chose the b1 to bm as type 1 and c1 to ck as type 2, then your final gain would be this quantity right here, where it depends on the x, right? Of course it depends on the x, like whatever is the final rank of that player, it depends on that. So we have this function, let's say f of x, which is telling us that how much will we gain. And you can see that it is a linear function, like it is f of x, is linear in x, right? And we want to find out the worst case, right? Like we want to maximize the worst case scenario. So where will the worst case of f of x will be? Like if if I have this function which depends on x, like let's say I choose some strategy and I want to find out that what is the worst case of it, then which values of x should I check for the worst case? Like basically in this range of L comma R, I want to find the minimum value of fx, right? So for some strategy, I can find out the fx and I want to find out the minimum value of fx in this range L comma R. So where would be the minimum? If fx is linear, so where would be the minimum? It would be either L or R, right? Like if I make the graph of it, the graph would look like this. It is linear. So the minimum would be either at L if it is upward sloping, or if the graph is downward sloping like this, then the minimum would be, this is L, this is R. So the minimum would be at R, right? So that's how, like that's what you can observe about this function, that your worst case will either be at L or at R. Okay, and your final outcome is linear in X. Like once you have finalized your um, like your once you have finalized your strategy, the output is linear in X, and this is the output. Okay, but now the question is, how do you optimize your strategy? Okay, so until here, do you all get it? Like what I just said was, for a given strategy, you will have the equation that is fx. Like basically, the type 1 bets would be bi minus x, like b1 minus x plus b2 minus x plus up to bm minus x plus the type 2 bets, which is x minus ci, x minus c1 plus x minus c2 up to x minus ck, right? So this is your fx. Like for example, in this test case, if I place my bets like this, that let's say I bet that my x would be greater than equal to 1, then I would get x minus 1 coins. Then let's say I bet that my x would be greater than equal to 3 as well, then I would get x minus 3 coins. Then let's say I don't bet anything on 5. Okay, so it would be 0. Then let's say I bet that x would be less than 7. So I would get 7 minus x coins. And let's say I bet that x would be less than 9. So I would get 9 minus x coins. So this is the final function, which is a function of x. So if I place bets like this, then I will get this much amount of profit. And I can find the minimum value of this in the range L comma R, which is 6 comma 10. And actually, if you see, this function is actually constant because x cancels out. Okay, so you get 12. So if you do this strategy, then you get 12. Okay, but there's a better strategy that will give you 13 as well. That's what they are saying. But yeah, in this strategy, you'll always get 12 as your answer. So until here, do you guys get it? Okay. So now what we can actually do, like now what's left? Basically, we figured out that for a given strategy, what is our profit? What is our profit? We found that. and it came out to be a function of x, obviously, and it is a linear function in x, a linear function in x. So if you want to find out that what is the, like, they have defined this score, right? The score of a strategy. That is the maximum, the number of robocoins you are guaranteed to earn. That is the minimum number of robocoins that you earn over all the values of p in L, R. So this fx is linear, which depends on x, the final value of p. And since it is linear, we know that either the minimum value would come out at L or at R, right? So that's how we can find out the score of some strategy. Like we can just find out this polynomial and we can evaluate at L and also at R. And then whatever is the minimum of them, that's the score of the strategy. But now what do we, like, how do we find out the maximum possible value or maximum score? How do we find it out? So for that, what we can do is, I have a few observations. Okay, like instead of looking at, like just look at this equation. Just look at this equation very carefully. Okay, that you have some positive bets and you have some negative bets, right? So my point is that, um, let's say you have a value 5 and a value 7. Okay, and also some other values also you have in this array. Let's say you bet that x would be less than equal to 5, and also you bet x would be greater than equal to 7. Like for this 5 you bet that it would be less than equal to 5, and for this 7 you bet that it is greater than equal to 7. Okay, so this is actually never a good option. Why? Because in your function, if you, in your fx, what would you have? You would have 5 minus x, right, plus x minus 7. Okay, so this turns out to be minus 2, right? But instead, if you had just done the opposite, that x is greater than equal to 5 and x is less than equal to 7, if you had placed these bets, then in your fx, you would have gotten x minus 5 plus 7 minus x, which is equal to 2. Okay, so this is what the thing is. Like, you will never place a bet like this. You would never place a bet like this, which is x less than equal to 5 and x greater than equal to 7. Like intuitively also it makes sense, right? Intuitively, you would never place a bet which says x is less than equal to 5 and also x is greater than equal to 7. Like you are saying two different things, right? So this is never a good option. So basically, if you say that this is a blue bet and this is a red bet, then what I am saying is, um, a blue bet will never come before a black bet. Like you have the array, right? You have the array a1, a2, a3, a4 up to an. And let's say we sort it. Okay, let's say we sort it. Then what I'm saying is, you have to choose either a blue or a red for each element, right? For each element, you have to either choose blue or red. So what I am saying is, you will never choose a blue before a red. Like any blue can never come before a red. And why is that? That is because it will give you a worse condition. Like here, if you choose this blue and this red, then for from this, what you will get is a2 minus x, and from this you will get x minus a4, right? So finally, this is just a2 minus a4. But instead, what you could have done is you could have made it red. You could have made it red, so you would have gotten x minus a2, and you would have made this blue, so you would have gotten a4 minus x. So in this case, you are getting total of a4 minus a2, and a4 minus a2 is definitely bigger than a2 minus a4 because a4 is greater than a2. Okay, so all the blues, like no blue can be before any red. Okay, that's what the thing is. that all reds would be before all blues. Before all blues. Okay. Is this clear, guys? So now the array can look like something like this. Like let's say A1, A2, A3, A4, A5, A6. Then it might happen that this is red, this is red, this is red, and let's say this is blue. So this is still possible until now. Like I just said that all the reds will come before all the blues. Because otherwise you can just exchange them. And your score will definitely increase in all the cases. Right. And then this is one thing, right? And one more thing is that you will never have a gap between this red. Okay, like here you can see we have a gap. That is, we have a white right here, right? But you won't have a gap. You will never have a gap. Why? Because you can simply move a red right here. Like in this case, what is the value? Like you will be getting x minus a4, right? This is a red bed, so red bed gives you x minus a4. But actually, what you could have done is instead of this, you could have used this one. So in that case, you would get x minus a3, and all of these would be same, right? And definitely x minus a3 is better than x minus a4. So you will always choose x minus a3 over x minus a4. So that's why you will always choose the red to be the left ones, right? So this can also never happen. That a1, a2, a4. This is also never going to happen. You will always choose left, like you will always choose some left ones as the red and some right ones as your blue. Okay, this is what we have now. That some prefix of this array would be red. Some prefix would be red, and some suffix would be blue. Okay. And then finally, there's one more thing that I can tell you, that you will never have more than one of these white ones. Like here you have two whites, right? You have two whites right here, but you will never have more than one of these white. Okay. So until now we have this, that some prefix would be red and some suffix would be blue. And in the middle there will be white. But actually, there can never be more than one white. Why? Because if you have two whites, then you can simply make them red and blue. See, in right now, from these two you are getting zero, right? You are getting zero. But actually, what you can do is you can mark this one as blue. So A5 as blue, and you can mark A4 as red. So finally, like in that case, what you will get? You will get A5 minus x plus x minus A4. So this is just A5 minus A4, right? And since we know that A5 is greater than or equal to A4, like it is sorted, right? So this is definitely better than 0. So if you have two whites, then you can just make them one red and make one blue, and you will get this better value, right? So conclusion is that there can be at most one white, at most one white. Okay. So we have these three conditions, that a prefix would be red, a suffix would be blue, and at most one element would be white. So now you can simply just try all the possibilities, right? Because if you have a given array, like if you want to satisfy all these three conditions, a1, a2, a3 up to an. So if you have that some prefix is red and some suffix is blue, and only one element can be white, then you can simply iterate on the white element, right? you can simply iterate from 0 to n minus 1, that which one is the white element. And to the left of it would be all the red elements, and to the right of it would be just all blue elements. And then you can simply evaluate the function, the f of x, and you can put L and R in it, f of L and f of R, that and take their minimum. So the minimum would be this strategy's score, right? And whatever the maximum score that you are getting using this, you will simply return that. Okay, that's the actual solution. Okay, you have one more solution, I guess. For example, for test case 4, all n value are 93175, so mid is 5. So 5 will always give minimum answer. But 5 is not in the range, so P will be as close to 5, which is 6. So you are saying that whatever is the middle value, find its nearest in the range and then just place bets accordingly. So that might be correct, but I don't have the proof of that. Like I knew one solution which I have the proof of also, so I told that one. Like I just proved everything I said. Like in this solution, I told you why a prefix would be red and a suffix would be blue, right? And why there can be only one white cell. Like I just proved all of these things. So that's why I told this proof. Like I told this solution. But it's possible that yours also might be correct. But is there any doubt, anyone? No doubts. Okay. So let's move ahead with the code. NLR, input the array, and then I sorted the array, right? And then to evaluate the function at every point, like if I assume that this is the white cell, then I'll have to have the sum of this range and also the sum of this range. So for that, I created prefix and postfix sums. So I have this prefix sum and I have this postfix sum. So prefix of I contains the sum from a0 to ai, and postfix of I contains sum from ai to an minus 1. Okay, so I just created these sums, and ans equal to 0. So my ans contains the maximum possible score that I will get. Okay, so for int I equal to 0, I less than I plus plus. So here what I am doing is I am assuming that the ith position is my um, white cell. Okay, so ith one is white, then before I they are all uh, red, and after I they are all blue. So the number of red elements is I, and the number of blue elements is n minus 1 minus I. Okay, and also, so I just calculate the polynomial. Like basically, if I have from a0 up to ai minus 1, that is red, then ai, and then a of I plus 1 up to a of n minus 1, then the polynomial that I have, like what is that? Essentially, it is a0 minus x plus a1 minus x up to a of I minus 1 minus x plus x minus a of I plus 1 plus x minus a of I plus 2 up to a of x minus a of n minus 1. So this is your polynomial. So with x, what you will get is like I into like n minus 1 minus I, the number of terms, like these are n minus 1 minus I number of terms, n minus I, these are I terms. So here x appears as negative, so I did minus I, and here x appears positive, right? So this into x plus the prefix sum from a0 to ai minus 1. So prefix sum of I minus 1, right? And then the in negative, I have I plus 1 say n minus 1. So minus postfix of I plus 1, right? Or did I mess up? Okay, yeah, actually it is reverse, right? It is x minus a0 plus x minus a1 up to x minus ai minus 1. So yeah, you get the point, right? This would become I minus n minus 1 minus I into x plus postfix of I minus 1, sorry, I plus 1, and minus prefix of I minus 1. Okay, so I just did b is equal to right left minus right, that is I minus this, so b is this. I'm just writing this function as bx plus a. Okay, so the value of b is this, and the value of a is post of I plus 1 minus pre of I minus 1. And I just check the boundary conditions. Okay, and then the score is what? The score is the minimum of the function evaluation at L and at R. So minimum of a plus bl comma a plus br, and we can just take the max with ans, right? So this was the case where ith is white. Okay, and what if no one is white? So for that I have this case where 0 to I is white, and sorry, 0 to I is red, and I plus 1 to n minus 1 is blue. So similarly I just performed the operations. Similarly I just did the calculation that the number of left elements, that is the number of red elements, is I plus 1, and the number of blue elements is n minus I minus 1. And like I just calculated a and b, and the similarly ans equals to max of ans comma min of a plus bl comma a plus br, right? And इसमें there is one case remaining where all are red. Okay, sorry, all are blue. So the case where all are blue, it is not coming in this for loop, so I'll have to handle that separately. So a is equal to pre of n minus 1, and b is equal to minus n. So ans equals to max of ans comma min of this, min of a plus bl comma a plus br, and finally just print the answer. Okay, so I just check all of the cases that could have been, right? Like in summary, what I did was I just proved two things. One thing is that all red is a prefix, and all blue will form a suffix, and also at most one white. Okay, so this is what your solution looks like. The proof is minimum distance from all given value have minimum total absolute value of sum. Think it like a number line, all value are going to a single point. Well, I think like you might be correct, but I can't think about it right now because I have to discuss the next problem as well. But I'll think about it in my free time, and the others can also think about it. Anyways, let's move on to the next one. Okay, adjusting drones. You are managing a fleet of n drones, each with energy level a1 to an. You are also given a positive integer k, which represents the maximum number of drones allowed at the same energy level. To prevent overloads, the drones automatically perform an energy balancing operation as follows. While there exists an energy level that appears strictly more than k times, they execute the following steps. First, every drone I, whose energy AI appears earlier, is marked. Then for each marked drone, its energy is increased by 1 unit. Then the marks are removed. The process stops once no energy level appears more than k times. Determine how many energy balancing operations will be performed. Okay, so the problem is pretty simple. They are saying that we have an array of A1, A2, A3 up to AN, right? And the constraint is that every element should appear less than equal to k times. So the frequency of each element should be less than equal to k. All right. And then what we have to do is, like, we have to prove, or basically we have to find out that what is the number of operations that will take to make this condition true. So in one operation, what happens is, let's say we have an array. Like, let's take an example. Let's say we have this 132, or let's say we have this array 111 2 3 3, 111 2 3 and 3. So basically, let's say k equals to 1. Okay. So what they are saying is, while there are elements which have greater than or equal to k frequency, then in that case, what you will do is you will iterate in the array from left to right. Okay. So this is 1. Okay. Then this one appears again. So we will mark this one. Okay. Then this one appears again. So we'll mark this one. Then there's a 2. Okay. Then there's a 3, right? And then this 3 appears again. So we mark this 3, right? And then all of the marked indices are increased. So it becomes 1, 2, 2, 2, and 3 and 4, right? So still there are elements which have more than one frequency. So we will again do it. So 1 is there, it is fine. 2 is there, it is fine. Now 2 is there again, so it is marked. And then 2 is there again, so it is marked. Then 3 is there, it is fine. 4, it is fine. So now these two marked ones are increased. So 1, 2, 3, 3, 3, and 4. Now again there are these elements. So we have to do it again. So 1 is there, fine. 2 is there, fine. 3 is there, fine. Now 3 is there again, so it is marked. And 3 is there again, so it is marked. And 4 is there, it is fine. So it becomes 1, 2, 3, 4, 4, and 4. And again, these two 4s are marked. So it becomes 1, 2, 3, 4, and 5, 5. Right? And then this 5 is again, like, this 5 is the first time, but this 5 came once again. So this is marked, and then it becomes 1, 2, 3, 4, 5, 6. Right? So basically we did how many operations? 1, 2, 3, 4, 5. 5 operations. So in this test case, if k was equal to 1, then the answer would have been 5. Okay. But since the k was 2, so we could have stopped here. Like, since the k was 2, we can stop here. So in that case, the answer is 4. And that's why the answer to this one is 4. Right? So we have to solve this. Like, basically, we have to determine that how many times this option will perform. Okay. So is the question clear? I think the question should be clear. It is pretty simple. Okay. So what actually we can observe in this, I'll explain one by one. All right. So the first thing is, can't I just rephrase the problem in a different way? Like, can I just say that if I have some elements, let's say I have 1, 1, 1, then I have 2, 2, then I have 3, 3, 3, let's say 4 threes I have, and then I have a single 4, let's say. So I have these 10 elements, right? So if I want to do the operation, can I just say that I can increase, like, I can just choose one element and make stay it same, like that one stays the same and the other ones will increase. So these two ones will increase to 2. And let's say in this group, this 2 stays the same, and the other one becomes 3. And in this 3 group, this 3 stays the same, and the other ones become 4. Right? So can't I just say that in one operation, one instance of every number, one instance stays same, and the other ones increment by 1. Right? We can say that, and this will keep happening until there are all less than equal to k frequency of elements. Right? So in fact, the like what I just proved here is that in the array, the order does not matter. The order doesn't matter. Okay. Like basically, um, the order of the elements in the array, it doesn't really matter, because what you are simply doing is just incrementing all the instances of each element except for one, right? So you can just choose any one of them. It doesn't really matter, right? It doesn't really matter, because finally you are not checking the order, you are just checking the frequency. So if you just play with frequency only, then the order doesn't matter, right? So do you guys get this? Why the order doesn't matter? Do you all agree? Yes. Okay. So now what we can actually see, like what we can do is to make our lives a little bit easier. Let's just sort the array. Okay. So let's say we have this input array 1 1 1 2 3 3. Okay. So let's sort the array. Right. I mean it is already sorted. So okay. Now what we can do is we can do the operations, and in fact we can actually change the type of thing that we are doing also. Like they are saying that um, whenever there's a tie, like which one to choose. Like there are three elements, so which one out of these three should we keep the same? So they are saying that keep the leftmost same. Okay, but let's say we keep the rightmost same, and instead like increment the left ones. Okay, or let's just try to observe what will happen. Like let's say we try to keep this left one same, then what will happen? So it would be actually I did this already, right? In the above example, I showed this already, that what is happening. Um, but okay, like the entire point here is that the order doesn't matter. So first we'll sort the array. All right. And then also one more thing is that we can choose any element. We can choose any one element to keep fixed. To keep fixed, right? Basically, what they are saying is just keep the leftmost one fixed and increment the other ones. Like make this two, make this two. But we can change that also. Like we can choose any one element by our choice, and it won't change the answer, right? So let's say we choose the rightmost element instead of leftmost. Okay. So let's say I chose the rightmost element and I draw the array. Okay. So let's say I have this 1, 1, 1, 2, 2, and 3. And let's say I choose that the rightmost element won't change. Okay. So what will happen? It will become 2, 2, 1, 2, 2, 1, 3, 2, 3. Right. Then there are three twos. So this one will change like 3, 3, 1, 4, 2, 3, right? Do you agree? Like, I'm just not changing the rightmost element. So 3, 3, 1, 4, 2, 3, right? Then there are three threes, so these two will increase. So we have 4, 4, 1, 4, 2, 3, right? These 1, 4, and 2 are distinct, like there are only ones. Okay. Then we have three fours, right? So this one won't change. So I will have 5, 5, 1, 4, 2, 3, right? And then I have two fives. So um, yeah, I have these two fives. So I can, like, I'll not change this right one. So 6, 5, 1, 4, 2, 3. So you can see that this array looks like this. Like the final array looks like this. Okay. 6, 5, 1, 4, 2, 3. This 1, 1, 1, 2, 2, 3 converted to 6, 5, 1, 4, 2, 3. Right. So actually, can you determine that? Can you find out this array using this array? I mean, sorry, if I give you this array 1, 1, 1, 2, 2, 3, then can you actually find out this array? Like, is it possible to do it in O of n? Can you go from here to here directly? Like, until all the elements are distinct. If you keep doing this, like if you don't touch the rightmost element, then what would be the final array? How would you create that? So actually, there's a pattern. Okay, like of course, if you are not touching the rightmost element, if you are not touching the rightmost element, then of course the rightmost element would be the same, right? Like in the array, the last element, it would always stay the same, right? It would stay the same. Okay. Then let's say you have two here, right? So you have two here. What does that mean? It means that since this is 3, okay, since this is a 3, that means that this is the last occurrence of this 2. Like this element here is the rightmost occurrence of this 2. So this 2 also will not change. Okay. Then you have a 2 right here, right? So since this 2 is not the rightmost occurrence, it will change. Okay. So it will change to 3. But then this 3 also is not the rightmost occurrence because there's a 3 already here. So it will change to 4. Right? But since there is no 4 to the right of it, this 4 will remain 4 only. Right? So 4 will remain 4. So basically, 2 will become this 4. Like we can just see that what is the next number that has not occurred in the right. Like 2 and 3 have occurred. So it will become 4. Okay. Do you get my point? Like until now, this 2 and 3 have occurred. So this one will become 4 because it is not the rightmost occurrence of 2. And also when it becomes 3, it is not the rightmost occurrence of 3. So it will become 4. But now it is the rightmost occurrence of 4. So it will stay as 4 in the final array. Right? So now we have 1, like 2, 3 and 4. Right? Now we look at this 1. So since this 1 is not there on the right, that means it is always the rightmost occurrence of 1. So it will stay the same. Right. Then I have this 1. So since this 1 is not the rightmost occurrence, it will change to 2. It changed to 2. Then since this 2 also is not the rightmost occurrence, it is this one. So it will change to 3. Then since this 3 is not the rightmost, it will change to 4. And basically 4 will also change because it is not the rightmost. So it will change to 5. And like 5 is the rightmost. Like here, 5 has not occurred yet. So it will remain 5 only. So finally, this 1 will become 5. Why? Because 1, 2, 3, and 4 are already taken. So 1 will become 5. So you can see that what is the actual pattern here. That if you iterate from left to right, sorry, from right to left, you will look at this 3 and you will see that like you will say that it will end up as 3. Okay. Then you look at this 2 and you will say that this 2 will end up as 2 because there is no 2 on the right. Okay. But now you look at this 2. So if you look at this 2, you will see that this 2 will end up as not 2 because there's a 2 already here and there's a 3 also already. So it will end up as 4. Okay. So basically, the final value, let's say the final value is bi. The final value is bi. Then your bi is the smallest number which is greater than equal to ai, which has not appeared yet. Not appeared yet. Okay. So that's how you can find out the final array. Okay. This is how you can find out the final array. Like I'll take one more example. Let's say um, we have a huge example. Let's say I have one, 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 two, three, 5, 8, 8, 8, 8, 9. Okay. So this array will become, so 9 will remain as 9, then 8 will remain as 8. This 8 will become 10. Okay. Because 8 and 9 are already there. Then this 8 would become 11. Right. And this 8 would become 12. This 5 would become what? It would stay as 5 because there is no 5 here. Then this 3 would stay as 3 because there are no 3's here. Then this 2 would stay as 2. And this 1 would stay as 1. And this 1 would become 4 because there is 1, 2, 3 here. So it would become 4 finally. And this is the final array. Okay. So that's how you can calculate the final array from the original array. Right. But one more thing that you can notice is how the elements have changed. Like see, look at this 3. The final value of this 3 is 3, right? So it will be 3 only. Okay. This is this is remaining as 3 at each step. Then what about this 2? For this 2, the final value is 2, right? So it is remaining as 2 only. Okay. Then for this 2, the final value is 4. So at each step, it is incrementing by 1. Like this 2 becomes 3, 3 becomes 4, and 4 will remain as 4 because it is 4 only. So that's what the pattern is. Like this one, the value of this one is 5 finally. So it will change to 2, 3, 4, and then 5, and it will remain as 5, right? And the value of this one is 6 finally. So it will change as 1, 2, 3, 4, 5, 6. So that's what the pattern is. That for each element, it will move one step above until it reaches the final value, right? That's my entire point. Like you can observe this very very clearly from this um, demonstration, right? So basically, if you have an array element ai, right, and its final value is bi, okay, then your array element ai would change like this. Like before the first operation it is ai, then it would become ai plus 1, then it would become ai plus 2, up to bi. Like whenever it reaches bi, then it would stay bi only, bi, etc. Right? So basically, if you want that after m operations, like after m steps, what is your value of ai? Okay, if you want that, then how would you calculate that? You can just say that it is ai plus m, comma bi, the minimum value of these two, the minimum of ai plus m, comma bi. Like after each step, it increments by 1, but as soon as it reaches bi, it stops there. So it is min of ai plus m, comma bi, right? So you can find this out. So now what we have in our pocket is that we can find out the state of the array after some amount of steps. Like if I have the array a1, a2 up to an, and I want to find out that after k steps, or let's say after l steps, what is my array? Let's say b1, b2, or c1, c2. Let's say c1, c2 up to cn. So I can find that out very easily if I have already the b array. Like if I have the b array, then I can find out that what is this after l steps, and it is just the min of ai plus l comma bi, right? So I can find out, like by this technique I can find out what the array after l steps, and that is in o of n. In o of n time, I can find out that what is the array after l steps. Okay, so how can I use this technique? Like what I now want is that after which step does the array become less than k? Like after which step does the number of maximum frequency, like after which step does the maximum frequency become less than k? I want that, right? Like you can see, let's say in this test case, um, yeah, like in this test case, let's say the value of k was 2, right? The value of k was 2, then of course we could have stopped here. Okay, like see, if you calculate the value of highest frequency, so for this highest frequency is 3. For this it is still 3 because 2 has 3 times appearing, like 2 is appearing 3 times. Then for this array also it is 3, for this also it is 3, but for this it is 2, right? That means you can stop here. Okay, you can stop here by the time this value becomes 2, because k is 2. So you have to find out that what is the point after which the maximum frequency of this array becomes less than equal to k. Like what you have in your pocket is that you can find out the array after any number of steps in O of n time, right? And you want to find out that after how many steps is it less than equal to k. So what can we do for that? How can we check that? Any ideas? Like if we know that um, the array after L, like if we can find out that what is the state of this array after L steps, like after any number of steps we can find out the array. So we have to find out that after how many steps does its value become less than equal to k. So what can we do? Actually we can prove that this value is monotonic. Okay, like here you can see that the value is 3 here, the 3 here, 3 here, 3 here, it becomes 2 here, and for this one it is 1. Okay, so actually I can prove to you that whenever you apply the operation, then the value is definitely less than equal to the previous one. Like it is non increasing. Okay, like what I am saying is for a given array a1, a2, a3 up to an, the maximum frequency of any element cannot increase. Okay, like let's say I have some elements, like let's say the maximum frequency is k, or let's say f. Okay, the maximum frequency of some element is f. All right, that is the frequency of all the elements is less than equal to f. Okay, so what will happen if I do the operation is that let's say the value x, like I have an element x which has frequency equal to f. So if I do the operation, then there would be f, like there would be f minus 1 copies of x plus 1 created, right? Like there are f x's, right? X, x, x up to x. So the f minus 1 x's I will increment to x plus 1, right? So f minus 1 x plus 1 would be created, and initially whatever were the x plus 1s, let's say there were f2 x plus 1s, there would just be one left, right? Like only one would be left out of them. So x plus 1 would be at most f, right? So the maximum frequency was x previously, but now it is of x plus 1. Like the maximum frequency was f, which was belonging to x, but now it belongs to x plus 1, and it might be still f if f existed previously. Like I'll give an example: 333, 4 4, and let's say 5 5 5. So we have maximum frequency f equals to 3. So now even though these three, like these three becomes 4 4 and 4, and there were two fours, but when you apply the operation on this one also, only one of the fours will survive. So only one four will come, and you will again have three fours. So the frequency doesn't increase. Okay, the maximum frequency, the maximum frequency function is non-increasing, right? And that's why you can easily find out that after which step it becomes less than equal to k. Okay, you can simply do a binary search on the answer and just check that after L steps, what is the maximum frequency, and if you need to do more steps, then do more steps, right? Like just do a based on the answer. Okay, I hope it makes sense. Anyone? Like anyone any doubts? I guess there are no doubts. So I'll just show the code. Okay. Yeah. So like I have this check function. Okay, I'll first show the solve function. Yeah, so I have int nk, c in nk, input the array, sort the array, and then I'll make the array b. Okay. So first of all, I'll just insert all the numbers from 0 to 3n. Okay. Why 3n? Because um, like we cannot have elements more than 3n, because initially the elements are till 2n, and like in bi array the elements will not be more than that. You can prove that. Okay. Then what I'll do is, for int I equal to n minus 1, like in reverse, I'll find out the lower bound of ai, and then I will set bi to that value, and I'll erase it from the set. So basically, what I'm finding out is the first value more than ai, which is not there in the array b. So all the elements in the array b, I'm just deleting them from set s, right? So that's how I just create this array b, and then I do a binary search on the answer. So low equal to 0, high equals to 189. You don't need 189 actually, like you can just keep it 4 or something. But yeah, high equals to 189. And while low is less than high, I'll check for mid. So if not check, then low equals to mid plus 1. Otherwise, high equals to mid. And how does check function work? So in my check function, I will simply calculate the final array C. So my C is just min of bi, comma ai plus number of operations, right? And then I'll make the frequency array of C, and I'll find the maximum frequency. So if maximum frequency is less than equal to k, then I'll return true, else I'll return false, right? So that is the algorithm here. So is there no messages or is StreamYard bugging? Let's see on YouTube. I guess there are no messages because there are very less viewers. Yeah. So I guess there are no doubts in this problem as well. Alright, so if there are no doubts, then I will take your leave, I guess. And thanks everyone for watching. Okay. Bye everyone.